Good morning, students. So today our class is about coal. Here, what is coal? Coal means highly carbonaceous material. Highly carbonaceous material. Carbonaceous material means containing high percentage of carbon. So here the coal contains carbon up to 80 to 80 percentage. 80 to 85 percentage coal consists of carbon, and the remaining 15 to 20% coal consists of elements like nitrogen, sulfur, oxygen, hydrogen, and other impurities. Here, how coal is produced? The production of coal. Coal is produced in the deep earth crust during the decomposition of plant matter under anaerobic conditions. Decomposition of plant matter under anaerobic conditions. Here, generally when floods are happen, plant matter buried in the deep earth crust. So after so many years, that plant matter decompose and converted into coal. Here that decomposition takes place at drastic conditions, at high pressure, high temperature, and in the absence of air. So at such drastic conditions, the plant matter decompose and converted into high carbon containing material called coal. Here, based on the percentage of carbon in coal, different varieties of coal are found in the earth crust. Here, classification of coal. Classification. Depending upon percentage of carbon in the coal, varieties of coals are found in the earth crust. Here, the parent material for the coal is wood. The parent material is wood, starting material wood. Here wood decomposed into peat coal, lignite coal, bituminous coal, and anthracite coal. Here from left to right, from peat, lignite, bituminous, anthracite, from left to right, percentage of carbon increases in the coal. Percentage of carbon increases, therefore calorific value increases. Here anthracite is high percentage carbon containing coal, so its calorific value is higher compared to the remaining coals. Compared to peat, lignite, bituminous, anthracite possess high percentage of carbon, so its calorific value is higher. Okay, from right to left, percentage of impurities increases. Impurities means like the elements nitrogen, sulfur, oxygen, hydrogen, moisture content, and other volatile impurities. So here peat coal contains more percentage of impurities. Anthracite contains more percentage of carbon. With increase of carbon percentage, calorific value increases. Therefore, anthracite is a high ranking coal. Peat is low ranking coal. Next one. Here to analyze the percentage of carbon in coal, two methods are there: proximate analysis and ultimate analysis. By using these analysis methods, we can determine the percentage of the components in the given coal. Now, first analysis method is proximate analysis. Proximate analysis. Here, proximate analysis involves determination of percentage of moisture, percentage of moisture, percentage of volatile matter, percentage of ash, and percentage of carbon in the given coal sample. To determine the percentage of moisture content, volatile impurities, ash, and carbon in the given coal sample, this proximate analysis method is used. Now, first one is determination of moisture, determination of percentage of moisture in the given coal sample. So how do we determine percentage of moisture content in the given coal sample? Now, simply known weight of coal sample, known weight of coal sample is heated in electric oven, heated in electric oven at about 100 degree centigrade, at 100 degree centigrade for a period 1 hour, for a period 1 hour. Here the heating is done in the absence of air. Here, to determine the moisture content, known weight of coal sample is heated in electric oven in the absence of air at 100 degree centigrade for a period 1 hour. Here, during the heating process, the coal loses all its moisture content. Coal loses all its moisture content. Here, after heating, the coal sample is taken out from the oven, cooled and weighed. Here, from the loss in weight of coal sample, percentage of the moisture content is determined. So, percentage of moisture is equal to loss in weight in coal sample, loss in weight of coal sample by weight of coal taken into 100. Here how much weight of coal is taken and how much weight is lost into 100. Okay, here simply the coal sample is heated in electric oven in the absence of air. Suppose if we heat the fuel in presence of air, then complete combustion of fuel takes place. But here the heating of fuel in the absence of air for a particular period. After heating, the coal sample is taken out from the oven and it is cooled and weighed. So whenever the moisture is evaporated, the weight of the coal sample is decreases. So from the decrease in weight of coal sample, percentage of moisture is determined. Percentage of moisture is equal to loss in weight of coal sample due to the removal of moisture content by weight of original coal sample into 100. So in this way, moisture content is determined. Next one is percentage of volatile matter. Percentage of volatile matter. Here the volatile content, volatile impurities in the coal is determined by heating the coal sample at a high temperature, about 950 degrees centigrade, in the absence of air for a period about 7 minutes. 7 minutes. Here the coal sample is heated in electric oven in the absence of air at 950 degrees centigrade for a period 7 minutes. At such high temperature, the coal sample loses its volatile impurities. Volatile impurities are evaporated. Whenever the impurities are evaporated, the weight of the coal sample decreases. So from the decrease in weight of coal sample, percentage of volatile matter is determined. Percentage of volatile matter is equal to loss in weight of coal sample due to removal of volatile impurities by weight of original coal sample taken into 100. Okay, here in the first case, in the determination of moisture, the coal sample is heated in the absence of air at 100 degrees centigrade for a period 1 hour. Then the coal loses its moisture content and its weight is decreased. From the decrease in weight of coal sample, moisture content is determined. Percentage of moisture is equal to loss in weight of coal due to removal of moisture content by weight of original coal taken into 100. In case of volatile matter, the coal sample is heated in electric oven at high temperature, about 950 degrees centigrade for 7 minutes. So after heating, the coal sample is taken out, cooled and weighed. From the decrease in weight of coal sample, percentage of volatile matter is determined. Percentage of volatile matter is equal to loss in weight of coal due to removal of volatile matter by weight of coal taken into 100. Now next one is ash. Determination of ash. Determination of ash. Here the coal sample is heated in presence of air. Then complete combustion of coal takes place. Here the heating of coal is continued until a constant residue is obtained. From the weight of residue, percentage of ash is determined. Okay, here percentage ash is equal to weight of residue obtained by weight of coal taken into 100. Here ash is determined by heating the coal sample in presence of air. Then complete combustion takes place and a residue is obtained. From that residue, ash is determined. Weight of residue by weight of coal into 100. Okay. Final one is percentage of carbon. Percentage of carbon in the given coal sample is determined by subtracting these elements from the 100. Here 100 minus percentage of moisture content plus volatile matter content plus ash. Okay, so here carbon is equal to 100 minus moisture plus volatile impurities plus ash. So what is the importance of this analysis? By using proximate analysis, we can determine the percentage of moisture, volatile matter, ash and carbon in the given coal sample. Here what is the importance? Here moisture content. First one is moisture content. Here good coal should contain less percentage of moisture. Otherwise, the presence of moisture decreases combustion properties of coal. Therefore, heating value or calorific value decreases. That means quality of the coal decreases. And also, the presence of moisture in the coal, when coal is heated, that moisture is evaporated. That vapors carry some of the heat from the fuel. Carry away some of the heat from fuel. Therefore, loss in heat takes place. Therefore, calorific value decreases. So, good coal should contain less percentage of moisture content. Next one, what is the importance of volatile matter? Volatile impurity. Volatile impurity means easily volatile impurities. Here, Suppose if the coal consists of volatile impurity, if such coal is used in heating, here used in various industrial purposes, here when such coal is heated, the volatile impurities are vaporized. That impurity is converted into vapors. Here that vapors burn and produce heat. That heat is added to calorific value. Here compared to solid state, that vapors burn with long flames and high smoke. Therefore, large combustion chamber is required. Here, high volatile content in the coal means large combustion chamber is needed. And also, suppose if that vapors may escape from the combustion chamber, without burning, so that decreases the calorific value of coal. So here good coal should contain less percentage of volatile impurity. Next, ash. So fuel should not produce ash during the combustion, because ash is poor conductor of heat. That does not carry heat upwards, so that decreases the heating value or calorific value. So good coal should produce less amount of ash during its combustion. Next one, carbon percentage. So with increase of carbon percentage, calorific value of the fuel or coal increases. So good coal should contain high percentage of carbon. Okay, so coal contains only high percentage of carbon and less percentage of the moisture, volatile matter and ash. Okay, so it is about proximate analysis of the coal. Thank you.